Now, for time taken for the shot put, you just got to be careful because remember we've got that original kind of height of 2 meters. So what happens to the ball is it obviously like launches and then does a little projectile motion, but then it actually travels like further, like like a projectile motion. So what you have to do is kind of consider it into 2 different times and then add it together. So basically at the maximum height, you've got to figure out how long it takes to get to the maximum height, and then find that time. And then next you actually have to figure out how long it takes for it to fall from like maximum height. So and then you will add those 2 times together. So let's start with number 1 section. Let's write some facts down. So obviously this is a vertical component, so my A is 9.8. For the first section, my VOV is 7.07. My T is what I'm trying to find. What else do I know? My V, is end up going to be 0 because that's at the top. So let's use that equation. So V is V0 plus AT is the equation I'll be using. V is question mark, V0 is 7.07. Take 9.8 T. Oh, I did that badly. Hold on. So I meant to write 0 there because at the maximum height it's 0. So that's 0. So my T should rearrange to 7.07 divided by 9.8, which should give you 0.721 seconds. So that is basically this part, how long that took. Now we're going to do the next part for it to fall. Okay, let's write some more facts down. So this is section 2. I'll write section 1, section 2. Let's write some facts down. My A is obviously still 9.8. My V initial now, it's going from the top, so my V initial becomes 0. Alright, T is what I'm trying to find. My V at the end is going to be 0 as well. Alright, let's use those facts. Hold on. What have we got? Hold on, let's not do that one because it's not going to be helpful. My S is going to be 4.55 because that was the height of 2.55 plus the 2 over here. I did that in the previous question, so that's what I'll use. S equals, that's what we're using. And my V naught is 0, so that goes away. So my S is 4.55 equals half negative 9.8 T squared. So I just want to go down over here. My T should be 4.55 times 2 divided by 9.8 and then the square root of it. So that time ends up being 0.964 seconds. So that is section 2. So maybe I'll try to highlight it in a different color. So this section is that one. My yellow is that one. So we have to add them together. So therefore, total time is yellow section 721 plus 0.964. So that ends up being 1.69 seconds. That's it. C. Last, oh no, we've got a couple more. D. Calculate the range achieved by the shot put. Okay. So range is a horizontal component, so just take a note of that. Alright, so S is what I'm trying to find. My V horizontal was 7.07. My time taken for the whole thing was 1.69, so I can just use that one. Equation you want to use is V equals S over T, so my S must be VT. So I'll sub those values in. 7.07 times 1.69, which is going to give me 11.9 meters. And that's it. State the shot put's velocity at maximum height. Okay, well, maximum height, you're talking about vertical again. So my V is question mark. My V naught was 7.07. My A is negative 9.8. Well, technically, if you really think about it, I technically don't even have to even do any of these. Because, have a think, at that maximum height, if I draw my velocity, remember my V vertical should be 0, but my V horizontal should always be constant at 7.07 meters per second. So that's actually just my answer. I don't have to do technically any of this. You can, it's going to still give you the right answer, but it's a bit pointless because you already know it. Done. Alright, F, determine the shot put's velocity after 1 second. Okay, so my T is 1 second, V is what I'm trying to find. My A is going to be negative 9.8. My V naught V is going to be 7.07, I think it was. So I should be able to use these informations. So V equals V naught plus AT. V equals 7.07, take 9.8, so basically negative 2.73 meters per second. Now that's my vertical component. My horizontal is always same at 7.07. My vertical is downwards at 2.73, so you've got to figure out the resultant vector x, which is just going to be Pythag. We should be used to this stuff by now. Chuck that in your calculator. And there we go. Now, the angle. Remember, that's still a part of it. Just use tan theta. Opposite over adjacent. So my theta should just be inverse of that. Which is 21.1 degrees. So let's conclude that answer. I'm going to conclude it here. Therefore, my velocity when time is 1 second is, that looks like is 1 second is negative, no, not that, we've got to use this, always use a resultant one, 7.58 meters per second, 21.1 degrees below horizontal. Alright, sketch diagram that compares the path of the shot put with and without a significant amount of resistance acting. Okay, so it's basically just going to be a path. It's not going to be really parabolic anymore, and it's going to just have a smaller height and range because the air resistance probably will, like, for example, it'll start and it'll go up, but it won't go up as much. So if that's the original path, it will just be coming to the ground like so with resistance. So give your answer a read. There's not much really to it. It'll just not look like a parabola. And that's it.